Okay, so we saw yesterday, and then just going over the homework, this y equals c e to the kt. Does this look familiar to you?
Yeah.
Have you seen this before this class?
Absolutely.
You should have. You should have seen it in pre-cal and algebra 2 and also science. It may not have looked exactly like this, but it should be very similar type thing. All right, C is always going to be the initial value, the initial population, the initial amount, the money you put in your bank account, something like that. And Y is like your current or final amount. K is going to be a constant of proportionality, and T stands for time. And so this right here models exponential growth when K is positive. All right, imagine this. E, which is a positive number, raised to the power of another positive number, that's going to get bigger and bigger and bigger. Okay, as opposed to exponential decay, when do you think that's going to occur?
Negative.
When K is negative. And so you should be able to look at the problem and predict whether K should be positive or negative, and I would encourage you to do that because it's just a good way to check your work as you go. Okay, these are going to be two-step process problems, all right? You're going to first solve for K, and then you're going to answer whatever question they're asking you to do. You have to do this in 2 separate steps, all right? I may not teach this exactly the way you've seen it before. You may not remember this at all in your previous classes. That's fine too, because I'm going to teach it as if you've never seen it, although probably not as slow. I'm going to go, at a reasonable speed through this. So you might have questions, just ask. All right, so when you're, this is a good example of a exponential decay, half-lives, and I know you've done half-life problems before. And so you get this whole, suppose there's 10 grams of plutonium, so we've got some radioactive material. How long will it take for these 10 grams to decay, so they're telling you this is decay, to 1 gram, and then they give you the half-life. What you're going to maybe want to do is go straight into the question. How long will it take 10 grams to decay into 1 gram? The problem with that is you don't have all your information. You have to find K first. Okay, you have to find K. And the way you find K is by using the information that is, the one way we could say this is always true. And so using the information that's always true about plutonium, that's how we're going to find K. So like now that once we find K, that's true always for this particular element, okay? And so if the half-life is that's T, okay, I got that. I need to know K. What is Y and C if I'm talking about half-life? Yeah, half of 1. So I have half of whatever I started with times e to the power of k times 24,360. Now, if you wanted to put a different number here in place of c, like if you were like, no, it's 10 grams. Okay, well, fine. If you put 10 grams here, what would go on the left? 5 grams. And when you divide 5 by 10, you get 0.5. Okay, so as long as you have the ratio correct, you're going to be fine. If this was any other number besides 1, you would need to divide before you do the next step. Anybody have an idea of what the next step would be? Yeah, take natural log of both sides. So on the left, I have natural log of 0.5, and on the right, natural log of e to some power. That's just going to be the power, right? And if you're wanting to find k, you're going to divide. And this is a nice little shortcut that some of you may have already known, which is to find the constant for a particular half-life problem. It's just natural log of a half divided by the half-life. Okay? I just want to make sure you understand why that happens. In science, a lot of times you're just given formulas and you're using formulas, but this is math, and I want you to understand why it works the way it works. And so go ahead and in your calculator, let's plug this in. All right, and I'm going to pull my calculator up here as well. We're going to type it in. want you to go ahead and do diamond enter so that you get an idea for what this k really is. Because if I just press enter, it's probably going to just spit this back out to me. So this is how I get it decimal. Did any of yours put it into scientific notation for you? Like, does it say negative 2.845 times 10 to the negative fifth? Or does it say what mine says?
Mine just says 2.8.
2.8?
Yeah, mine says negative.
Okay, if yours doesn't go out as far as mine goes, then your decimal is being cut off.
Yeah.
All right, and so if you go to mode, you can change, where is that? How did I miss it?
Like change the number of digits?
Are you saying I passed it?
Oh, display digits?
Yeah,
Okay.
float.
Yeah, you should want it like on float or out really far, okay? And so that's the difference. You don't want, the thing is, you want this to be as accurate as possible, okay? And so here's something that we can do. We can store this number now in for k, because I want to keep the number as accurate as possible. Yes?
So you don't write it.
I don't care how you write it, because this is not my final answer anyway.
Okay.
So I'm going to store this in for k, and so just do alpha k. It doesn't really matter what letter you choose, and you can even see here that really my calculator is taking lots more digits than even it showed me the first time. Okay, you do not want to round until the very last thing in the problem. You want to make sure your calculator keeps accuracy. You could use the second answer feature, that's fine, but the store is nice because especially if you're doing multiple things within this problem set. All right. Okay, so then looking at the next part, all right, we found k. Okay, we found k. Then what I need to do, and you could write it down if you want, but honestly, that's only one part. Okay, this is good enough really as far as showing your work. So then we got to answer the question. Just make a projection. It says, how long will it take? So we're trying to find t for 10 grams to turn into 1 gram. And so in my y equals ck, the current amount would be 1, my initial amount would be 10, my k is the k from over here, and my t is what I'm looking for. Is this sounding familiar? Okay, so what should I do next then? So you could use the solver feature for sure, you could. And I could have done that up here as well. If I'm solving by hand, I really just want to do this just to practice the whole natural log thing. You use the solver feature. Feel free to do that. But what would I need to do? I would need to divide by 10. So before I do natural log on both sides. So now I'm ready to do natural log. So I have natural log of 0.1 equals kt. And so to find t, I'm just going to divide by k. On the AP test, some of the times it's going to look like natural log of 0.1 divided by this. So I really want to make sure you understand, you need to be comfortable with logs. But in the end, however you get your answers is good with me, okay? So then we're going to go back into the calculator and we're going to do natural log of 0.1 divided by k. And this only works if you stored it in for k. Oops. So that was not going to give me the right answer because I got to go back and put a parenthesis in there. Okay, so I get 80,000 years plus some. All right, your final answer should be accurate to 3 decimal places. So I'm going to write 80,922.168 years. I know it's years because my half-life was in years. You just use the same units.
And so when we do that with the t, you go into parentheses around, or the k, you always have to put parentheses around that variable, like when we divide by it.
Are you talking about the 0.1?
Yeah.
Your calculator automatically opens the parentheses when you do natural log, so yes, you have to.
Okay, but like we couldn't take, okay.
All right, so moving on to 2. I'm going to go quicker through this one because this is one that I know you've seen. And actually, I taught Algebra 1, and we introduced this in Algebra 1. And so you've seen this a lot, and this is a money problem. Now, we had y equals c e to the kt up here, but really when we're dealing with money, you're probably used to seeing the equation look like this. A for amount equals the principal of e to the rt, and r here is this constant. Okay, so it's saying, what's your annual rate? They're asking for the k, or the r, which we're going to change into a percent. And so here's another thing about this, you know, you guys are to the point now where you can be efficient with your work, and I know y'all are good at that, but some of you kind of work way too hard for what you get. In the 5 years, the amount of money in your account has doubled does not depend on 10,000. So when I'm trying to solve, I can just do 2 equals 1 e to the r times 5. You don't have to do 10,000 and 20,000. This saves you a step by doing this. It's just this is always going to be twice that when we're in the beginning. Take natural log of both sides. Again, if you want to use the solver feature, that's fine with me, although I don't really think this is that difficult. You need to be comfortable with using logs, so this is a good, nice practice. And so there's my r. All right, so I'm going to go ahead and plug it in, and since it's asking, I'm going to have to record this down because it's asking me for that r. So I'm going to take natural log of 2, and I'm going to divide by 5. And again, it just spits that back out, so I got to do diamond enter. And so I get this decimal, but really my answer should be the percent. And so I'm going to write it out as 13.863%. Okay? And I'm going to store that. And this time you can use K, you can use R. It doesn't really matter as long as you remember. And so now that's stored, ready for the second part. All right, so moving on to the second part. How much money will you have in 10 years? That's looking for Y. If we initially invest $10,000, we know the R. It's stored right here, okay? And 10 goes here. Am I going to have to take natural log of both sides to answer this question?
No.
No.
You just solve it.
Just plug that in. 10,000 e to the power of 10r. And 40,000. Now that seems too good to be true. Do you think we could have figured this out without going through all this work?
Probably.
My money's doubling in 5 years, and I'm asking about 10 years. How many times did the money double? Twice. So yeah, this is fine. You know, this is not going to be on the AP test. On the AP test, it's probably going to be like 11 years or something. Okay, so see what I mean? I just want to make sure you understand how to do this. Yeah.
Okay, so Y is the amount, it's the after value, and C is the initial?
Yes. Think of it this way. C is the initial condition of this problem. And it's the y-intercept of this problem as well.
And how do I know $10,000 is the thing that goes in the C afterwards? Or whatever?
Because they say initial investment of $10,000. It's a good question. All right. Yeah.
With compounding continuously, I know that was a big deal with Algebra 2. There was another one.
There was another one which was compounded monthly, blah, blah, blah. We're not going to do any of those.
Okay.
Okay. All right, so solve the differential equation. So this is a good review because you know you're going to have to do one of these on the quiz tomorrow. I will tell you this one's a little bit harder. First of all, I don't see dy over dx, but I see y prime. So I'm going to go ahead and make that substitution. And I'm used to seeing dy over dx by itself, so I'm going to go ahead and do that as well. I know I need to separate my variables. but I need to get dy over dx by itself. So what? I do want to multiply dx over to the other side, but I'm also going to need to get this y.
1 over y on the other side.
So I can't just divide only this thing by y. On this one, you have to factor. There's really no way out of this. But as soon as you factor, it's nice because you get separation. So yeah, you're going to multiply dx over to that side. You're going to divide by 10 minus y. So let me rewrite this so it's a little bit neater. Let me move it up as well. So we end up getting 1 over 10 minus y dy equals 5x dx. And once you get to this stage where all the y's are on the left and all the x's are on the right, this is when you're ready to integrate. Okay, and again, this is why we did integration for so long before this. Anybody think they know what this integral is without doing u substitution? So we know we're going to have natural log. We know we're going to have 10 minus y.
Oh, without use.
Little L in it.
I'm just saying, some people, I think, can do this figure C 2 steps ahead. Okay, but let me show you, there is an unexpected thing that comes out of this. Maybe it's unexpected.
Is it negative Ln?
Exactly. You've got to have the negative in front. And that's because derivative of negative y is negative dy. Alright, so you end up having negative 1 over u du, which is negative natural log u. And what I'm going to do is just go ahead and write it over here. Negative natural log 10 minus y. I think some of you can go from here to here and remember the negative. That's great. If not, you're going to have to go through the steps with the u and the du, okay? What about 5x? What's that antiderivative?
5 halves x squared.
5 halves x squared, and we know we have our plus c.
C.
All right, now I have a negative now. I have to deal with this before I rewrite this. So I could multiply everything by a negative, correct? So that would take that negative away. We would put a negative here. And how would that change plus
It would be
c?
minus c.
Well, does it matter if I put plus c or minus c? It's still just some number, right? So I'm just going to leave it alone. All right? And so now I'm going to rewrite this. 10 minus y equals e to the power of negative 5 halves x squared. And at this point, some of you are like, the c is going to go in front. Okay? And that's good. All right? You're right. This plus c is going to become c in front. Not because that's just something we do. We always put the number in front. This only works for plus c because I mean, this C could be 2, and this C would be like 3.9. I don't know. All right, it's changing. So we want to subtract 10 from both sides. And why do you say that, Brett? What's going to happen here with this negative?
Distribute the factor.
Yeah, multiply everything by a negative. And again, I don't have to do that to the C term. Okay, yeah, the value of C changed. I multiplied it by a negative. But you don't have to show that because I still don't know what C is. It's changing all the time. You just don't have to worry about it. And so this is what we call the general solution. All right? This is my general solution. It wants us, though, oh, never mind. That's it. That's all we have to do on this one, right?
Yep.
They didn't give us any other information. If they did, we would have to plug them in, x and y, solve for c, and so on. Yeah.
So you can just go straight from taking when you rewrite it,
Yes.
having tell your plus c of exponent, you can just go straight from it and get down.
Yeah. Like, I think for now, probably writing it and scratching it out and rewriting it is probably a good idea. And then later on, if you want to just go straight there, that's fine.
So then, if we can do the use substitution thing in our head, we don't have to write all of that?
On something as simple as this, yeah.
Okay.
But you got to make sure you're going to remember that negative.
Okay.
Because I promise you on a multiple choice question, there's going to be an answer choice where the negative's not there.
Okay.
All right, so I'm just trying to differentiate. Some of you are ready for that, some of you are not ready for that. And you know if you are or not. Okay, we're going to go through 4 really quick, and really 4 is just to prove a point. All right, so here's another differential equation. They're using t instead of x. And so we still need to get all the y's on one side and all the t's on another side. Okay, what we're really doing is we're starting with a statement, writing an equation, and in the end we're going to get something we've seen a whole lot. So I'm going to divide over the y. K here is just some constant,
Oh,
kind of like c. And then I would integrate. That would become natural log y. Now k is a number. So what's the antiderivative of the number?
K to be K source.
Now k is not a variable. It's going to be k times t. Yeah. Not k squared, 1/2 k squared. K is a number, so I got to treat it like a number. And I do have a plus c over here. So there's tons of letters on here. Just hang with me. The only other thing I need to do is rewrite this. All right? E to the power of kt plus c. And Catherine, this is what you were asking about is, once we see this plus c, we just rewrite it. Now, what does this look like?
Our initial formula.
Our initial formula. So if you ever wondered where that initial formula came from, it comes from this. It comes from a statement we know to be true, and then you use calculus. So you've been doing something related to calculus since forever. All right, you just didn't know. All right, we're not going to do this one. We actually already did that yesterday. And so I want to just go over a few things in the last part of class about a slope field. This will take us to the bell, I'm pretty sure. So remember, if you don't recognize the patterns, you just got to fill out a really long table. Okay? But these are some things to look for that is going to make especially matching a lot easier. You're going to look for places where the slopes are 0. We did that, right? We did that. And that's nice because it causes little horizontal lines. And so on this one, we can see there's lots of places where the slope's 0. Why would looking at slopes along the x-axis be nice? What's true about everywhere on the x-axis?
Y is 0.
The y is 0. And so there's commonality there. So that it could be that creates the same number each time, or it makes it easier to compute. What about along the y-axis? X is 0. All right, now for these next two, this I did not really talk about yesterday. All right, sometimes you only have x in your dx, dy over dx. So what I mean by this is dy over dx equals something, right? Sometimes there's an x and a y over here, but sometimes there's only an x. And when that happens, y doesn't matter. You're right. And that's what's happening in this problem right here. Think of it like this. Think of this x value. We'll say this is x equals 1, although it's really not. It's like pi over 2 or something. So if x equals 1, here we have a slope of 1, and the slope is not changing even though the y value is changing. So I know this equation. You may know what this is, but this equation only has an x in it. It does not have a y in it because the y does not matter. All right? Likewise, we could have one that only depends on y, where it goes left to right. Okay? Yeah. So this is sine, and the derivative of that would be cosine. All right. So I want you to skip this page. We're not going to do this today. I want you to go to this page. It's the last thing we're going to do. All right. So here are 2 differential equations and 2 slope fields. So this right here is what I'm going to tell you is how can you match slope fields without having to do all the work, because you're not going to have time to do that. All right, so if you look at these 2 equations, one of them depends only on x and one of them depends only on y. And if you know nothing else, you can look at these graphs and know which one depends on x. So number 1 says, which slope field shows slopes that depend on x but not on y? So which one, like, we'll say x equals 1 has the same slope everywhere x equals 1? B, right? Right here, it's the same. Everywhere x is 1, the slope is 1. Or I don't know if that's 1, but whatever it is, okay? So y's don't matter on slope field B. So if we only depend on x, which two of these must this be? Which one of these only depends on x?
Oh, of course.
The one with x. So that's dy over dx equals, I'm kind of answering question 3 here, but there we go. You see how I'm getting that? Then if we look at A, all right, see how, and this is the difference, see how maybe like when y is 2, when y is 2, the slope is the same no matter what the x is. So that's how I know that one goes with A. It only depends on y. Now, some people use phrases like parallel vertically and parallel horizontally. I'm really not, I say this only because some of you like to get help from DC. I'm not going to use that phrase because if I asked you which one was parallel vertically, some of you would answer A and some would answer B, depending on how you look at it. And there is a correct answer. But I'm just saying we're not going to do that. We're going to really say depend on X or depend on Y, and I want you to understand what it means. All right, these are the things that are going to help you with matching. Let me edit this.